Hello everyone, I am M. Vinita, Assistant Professor, Department of Mathematics, Dr. N.G.P. Arts and Science College, Coimbatore. In this video, we see the one of the familiar topic in mathematics, that is queuing theory. So, in this unit, we see introduction of queuing theory, basic definitions, reasons of queuing theory, and basic terminologies for queuing model, factors affecting the arrival, customers' behavior, some important terms, and Kendall's notation, one simple example problem. So first introduction. What is queue? A queue is nothing but a line of people or vehicles waiting for their turn. Queuing theory means it is the mathematical study of waiting line or queue. This technique provides basis of decision making about the resource needed to provide a service, or otherwise the service time to a customer is more than the arrival time of the customer. Why we study the queuing theory? Some reasons are given below. The first one, to find out the cost of offering the service, and the second one, to find out the cost of inherent due to delay in offering service. The third one is to allocate the resource. Some basic definitions. Customer. What is customer? The person or element. Element means nothing but the machines or vehicles waiting in the line to get the service. Service means need of the customer. The customer get the service from the server. Service facility, system that provides the service. For example, we went to the hospital, the doctor attend the patient. So the doctor gives some service to the patients. So the doctor is not only a service facility, the whole hospital, nurse, peon, all of them are called a service facility. Basic terminologies for queuing model. We consider the saloon shop. So how many customers are waiting in the queue before the service, that is called LQ, that is average length of the queue, and LS is the how many customers are waiting in the whole system, that is called LS. So LQ is the average length of the queue and LS is the average length of the system. Next WQ. WQ is the average waiting time in the queue. That means how long the customer waiting in the queue before the service. WS means the average waiting time in the system. That means how long the customer waiting in the system after the service. In above example, LQ equal to 5. That means there are 5 members are waiting in the queue and LS equal to 6 because 6 members are present in the whole system. So LQLS equal to 6. Some factors affecting the arrival. The first one is size of calling population. There are two types, finite and infinite. Infinite means market. Any person to went to the market and buy something. Finite means ration shop. Because who get the ration card in particular ration shop, that person's only to went to the ration shop. Next, nature of arrival. These also the two types, random and constant. For example, market and saloon shop, beauty parlor, anything. The customer's arrival days differ from day to day, but constant means the doctor must attend 100 patients per day only. So that is constant. Next, system capacity. The system capacity means limited or unlimited. Limited means in how many numbers, and unlimited means infinite. Fourth one is customer behavior. These are the four types. First one is bargaining. Bargaining is nothing but customer do not join the queue. The customer see the queue. The queue length was so long, so he decided he did not join the queue. Next one, reneging. Customer wait for some time in the queue but leave before being served. That is, he joined the queue but the queue did not move. So he have no time. So he leave the queue before the service. Next, jockeying. Customers move from one queue to another queue. So that means the customer standing in particular queue, but he saw the nearest queue. The queue length was very small, so he decided he jumping into the another queue. Next, one customer waiting in the queue, that customer represents more than one customer service. That means the bank counter, only 4 members are standing in the line, but the first member have 1 challan and second member have 2 challans, so third member have 3 challan and fourth member have 1 challan. So queue length is differ. That means equal to 7. Only 4 members are standing in the queue, but the queue length is 7. Next, some important terms. First one is arrival rate. Arrival rate is nothing but number of arrivals per unit time, that is denoted by lambda, and service rate means number of services per unit time, it is denoted by mu. Arrival arrival rate and service rate follows the Poisson distribution and it is a probabilistic in nature. Next one, inter-arrival time. That means time between two arrivals. Inter-arrival time is a reciprocal of arrival rate. So 1 divided by lambda. Inter-service time is time between two services. It is also a reciprocal of service rate to 1 divided by mu. Inter-arrival time and inter-service time follows the exponential distribution and it also is deterministic in nature. Next one of the important traffic intensity or utilization factor. It is denoted by rho. Rho equal to arrival rate divided by service rate, that is lambda divided by mu. The arrival rate must be less than the service rate. The value of traffic intensity less than 1. Next, some important formulas are given below. First one, average length of the queue, that is denoted by LQ equal to rho into rho divided by 1 minus rho. Next one is average length of the system, LS equal to rho divided by 1 minus rho. And next, waiting time in the queue. So WQ equal to LQ divided by lambda and waiting time in the system WS equal to LS divided by lambda. Next, Kendall's notation. It is one of the important part in queuing model. The general form of Kendall's notation is A bar, B bar, C such that D bar, E bar, F. A is a arrival pattern and B is a service pattern. Arrival pattern and service pattern follows the below three sections. That means M is a Poisson, it may be Poisson distribution, or D deterministic distribution, or EK Erlangen distribution. K means some constant. Next, C is a service channels, that is number of services, that may be 1, 2 or n times. Next, D is a service discipline. There are 4 types. First one is first come first service, FCFS. It is also called FIFO, that is first in first out. For example, saloon or market, anyone. So the people enter the saloon shop. So who enter the first in that shop, that person get the first priority. So also get the first service. Next, LCFS means last come first service or last in first out. For example, lift. 10 people entering the lift in first floor. He reaches the 5th floor. Who enter the last in the first floor, this person will come the lift from the 5th floor. Okay. Next, SIRO, service in random order. For example, lottery. In lottery, who get the money, we don't know. So that is the service in random order. Next, priority service. For example, the doctor attend one patient, but the emergency patients will come. So the doctor must attend that emergency patient. That means the priority service. Next, E is the capacity of the system and F is the size of calling population. These two may be n or infinity. That means limited or unlimited. Next, one of the example problem in a given MM1 queuing system. MM1 means Poisson distribution. The average arrival is 4 customers per minute and rho equal to rho means lambda by mu equal to 0.7. And what we find, mean number of customers in the system, mean number of customers in the queue. Third one, probability that the server is ideal. Ideal is nothing but it is denoted by P naught equal to 1 minus rho. Rho means lambda by mu. So 1 minus lambda by mu. Next, fourth one is mean waiting time in the system. Fifth one, mean waiting time in the. So we go to the solution. This model is MM1 infinity, first come first service method. So mean arrival rate, that is lambda already given, 4 customers per minute. So rho equal to already given, that is 0.7. How we denote rho? That is lambda by mu. So lambda by mu equal to 0.7. We substitute the value of 4, we get the value of mu. So mu equal to 40 divided by 7. Next, mean number of customers in the system, that is denoted by LS. The formula is lambda divided by mu minus lambda. Next, we substitute the value. So we get the answer 2 customers per minute. So next one is mean number of customers in the queue. That is denoted by LQ. The formula is lambda square divided by mu into mu minus lambda. It is separated lambda by mu into lambda divided by mu minus lambda. We know the lambda by mu. Lambda by mu is rho. So 0.7 into lambda divided by mu minus lambda is 2.33. So we multiply, we get 1.631. So approximate 2 customers waiting in the queue. Next, probability that the server is ideal is denoted by P naught. So 1 minus lambda by mu is the formula of P naught. So 1 minus lambda by mu is 0.7. So 0.3. Ideal is 0.3. Next, fourth one is mean waiting time of a customers in that system. That is denoted by WS. The formula is 1 divided by lambda into ls. So 1 divided by 4 into, we know the value ls previously we find. So 2.33, we substitute, we get 0.58 minutes. That means the customer waiting in the system after the service in 0.58 minutes. So mean waiting time of a customer in the queue, WQ equal to 1 divided by lambda into LQ. We already find the value of LQ. So we substitute, we get 0.41 minutes. That means the customer waiting in the queue 0.41 minutes. Finally, in this video, learn what is queuing theory, importance of queuing theory, discuss about customers' behavior, some important terms, learned Kendall's notation. Thank you all watching this video.